Chapter 4, Exercise 4.107. Calculate the empirical formula for each of the following stimulants based on their elemental mass percent composition. Part A, fructose 40% carbon, 6.7% hydrogen, 53.28% oxygen. These three numbers are the mass percentage. So usually we'll just assume 100 grams of sample. And then we have 40 grams of carbon, 6.72 grams of hydrogen, and 53.28 grams of oxygen. It's just convenient to assume 100 grams of fructose in total. Now I'm going to use mushroom chemistry, Wolfram alpha, to compute the number of moles. We have 40 grams of carbon divided by 12. The number of moles of carbon is 3.33. So I'm going to just write down, assuming a 100 gram sample. We have 3.33 moles of carbon. Hydrogen, 6.72 moles of hydrogen, or just maybe 6.7 moles of hydrogen roughly, because the molar mass of hydrogen is roughly 1. Oxygen 53.28. We'll use Wolfram alpha divided by 16, roughly 3.33 as well. So 3.33 moles of oxygen. What I usually do is I just compare the three numbers and find the smallest number, which is 3.33. So every single number divided by 3.33 divided by 3.33, and over here I got one carbon, 2 hydrogen, and finally this is just 1 oxygen. So it's going to be this: 1 carbon, 2 hydrogen, 1 oxygen. Again, the ratio is 1 to 2 to 1. So that's the empirical formula. If we have the molar mass, we can determine the molecular formula as well, which should be an integer multiple of this. Alright, I think they also assume 100 grams of sample because it's just convenient. And then we have 40 grams of carbon, 6.72 grams of hydrogen, and 53.28 grams of oxygen. They got this three fractional numbers, and all three numbers divided by the smallest subscript. They get 1-to-1 ratio as well. Part B, more difficult: caffeine found in coffee beans. We have this much carbon, hydrogen, nitrogen, and oxygen. Again, let's assume 100 grams of caffeine. So carbon is 49.48 grams. Alright, let's compute the number of moles of carbon. 49.48 divided by 12. Let's see. Uh, 4.123. Okay, we'll just keep this number. Carbon 4.123 moles. Now hydrogen, let's look at hydrogen. 5.19 grams of hydrogen. 5.15 or 5.149. Alright. Nitrogen and oxygen. Nitrogen 28.85. The molar mass of nitrogen is 14.01, so we get 2.059 moles of nitrogen Finally, oxygen 16.48 grams. Oxygen has a molar mass of 16, so we can do just calculation in our head. It's 16.48 divided by 16, and you will be able to get 1.03, right? So alright, now we have the number of moles for carbon, hydrogen, nitrogen, and oxygen. We look at these four numbers, we find the smallest number 1.03, and then every single number divided by 1.03. Alright, divided by 1.03, and this divided by 1.03. Well, of course, the last division is just 1. This division, well, you can see this as 2.06. Alright, so it's going to be 2. This one, it's going to be 5. Alright, so this is close to 5.15. Divided by this, that's 5. And over here, this is 4.12 over 1.03, that's 4. So the ratio should be 4 carbon, 5 hydrogen, 2 nitrogen, 1 oxygen. C2H5N2O. C4H5N2O. If you have only one oxygen, you do not have to specify the subscript 1. 4521. Alright, I think mastering chemistry is using the same strategy. For example, they assume there's 100 grams of caffeine. It contains 16.48 grams of oxygen, and they got 1.3 moles of oxygen. They got this formula, and every single subscript divided by 1.03, we have the empirical formula in the end.